My name is Drew Hogan. I'm a computer engineering student at Utah State, and today I'm going to talk about this theremin, which was my final project in my embedded systems class. The theremin is an instrument which you play using the proximity of your hands to the instrument. On the left here, I can play notes ranging from 0 to 10, and on the right, I can play 24 notes ranging from C3 to C5. Right now we're playing note D4. Taking a closer look here at our circuit, we'll start with the DAC, the digital to analog converter. This pin outputs anywhere from 0 to 3.3 volts. Now that's what we use to create our sine wave. As you can see from our picture here, we update the DAC 64 times for every period of the sine wave. And that isn't it isn't a continuous signal. Obviously it's discrete, but it's close enough that we're able to get an okay sound through the speaker. Now, when we're playing our highest note, C5, which is a 523 hertz sine wave, the DAC is going off over 33,000 times per second. So it has a pretty high frequency. Now, once we get our sine wave here, we go through a variable resistor, and then we have a low pass filter, which is used to center our sine wave at 0 volts. We pass through this amplifier and ultimately make our way here to the speaker. Additionally, we have our two ultrasonic sensors. Now, these sensors are a little bit nicer, where we can just send a message through UART, and then these sensors will respond in UART through their RX pin, and they will respond 2 different times with 2 different bytes, and you put those bytes together and you have your distance in millimeters, and we're able to do whatever we need to with that. Now, there's a third UART that communicates with our PC through the PuTTY terminal. Now, on the terminal, every time the volume or the pitch change, we update that in real time here, so you can see it as you're playing. As you can see here, the notes will update on the PC in the PuTTY console. Taking a look here at the software, as I mentioned, we're using FreeRTOS, so we're using tasks and queues to communicate between those tasks. We have a pitch and a volume task. They do exactly what you think they do. And then we have a task manager task here. This task manages the UART that communicates with the computer, because that's a shared resource between both the pitch and the volume tasks. We don't want that to be accessed at the same time by both of them. So if we look a little closer here at this volume task, first we enter the suspend all section, where the scheduler, once we enter the section, the scheduler will not schedule another task until we hit this function here. And that ensures that after we send our command to the ultrasonic sensor, we wait until we've received both of those distances. From there, we put those distances together, and we've actually got a little bit of an averaging going on here to prevent the distance and pitch from jumping around too often if there's an outlier in the measurements. And then we go through this case where we update this float, and then from there that float is sent in this queue. Now, as I mentioned, the DAC is being updated quite often. So whenever this timer 4 interrupt is fired, we check if we're in the on state. If we are, then we call this update DAC function, which is right here. And within this update DAC, we essentially grab whatever is in this mailbox queue, this volume, which is a float, and we multiply that by the sine lookup table, which I should also show that. These are the 24 values we're cycling through. So to adjust the volume, we are just multiplying those by the float, which range from 0 to 1 by 0.1, so 0.1, 0.2, 0.3, and so on. And to update the pitch, we change how often this timer is being fired. So if we look at our pitch task, we are just updating the timer ARR right here. And these are defined variables. Now that task manager task that I mentioned just updates the pitch as such and the volume, and it makes sure that the only one of those tasks is writing to the PC at a time. So that's a quick rundown of the software.